Take two. So operations with absolute value. On the ALEX program, they already assume that you know what absolute values are. Absolute value, by definition, is the distance of a number from 0 on the number line. So if they gave you the problem, the absolute value of 3, they're saying, how many spaces is 3 from 0? You guys already know it's 3 places. If I did the absolute value of -3, how many spaces is -3 from 0 on the number line? 3 places. So most people just think of, oh, the absolute value just makes your number positive. Sort of in effect it does, because a distance is always positive. You don't say that you go from Agency Village to Sisseton and you drove -7 miles. Unless you're driving backwards, maybe. No, you still went 7 miles. So by definition, it doesn't say it makes it positive because you do have the absolute value of 0, which is still 0. When I am evaluating something with absolute values, I have to do inside the absolute values first. It's not like parentheses where you can use the distributive property. You simplify it into one number and then you do the absolute value. So if I'm doing this problem, 10 minus 9 is, yep, yell it out, 1. I don't know your names yet, so I'm not going to call on you. Then, after I've simplified it so I just have one number in the absolute value, I can get rid of my absolute values. The absolute value of 15 is? 15. Thank you. 15. There's a minus sign. The absolute value of 1 is? You guys are going to make this difficult on me? Oh my gosh. 15 minus 1? 14, there we go. See, life is much easier if you just holler stuff out. I do tend to talk really fast, so if I go too fast, tell me to slow down, and I'm assuming maybe you already know how to do some of this stuff. 6 minus 8, then, if I do inside the absolute value, is -2. So the absolute value of -2 would make that 2. There's a minus sign in between. The absolute value of 14 is 14. And 2 minus 14 is -12. This one does stay negative because we don't have the absolute values on the outside, which would change it to a positive like that third question does. So you'll notice on the third one we have the extra set of absolute values. We know that final answer is going to be positive, but we still have to do the problem. So I'm going to do inside this one first. 5 minus 11 would be -6. The absolute value of 13 is 13 minus the absolute value of -6 is? The absolute value of -6 is?
6.
I'm going to have to get out my list and start calling on people if you guys can't talk. These are still in the absolute values. 13 minus 6 is? 7, and the absolute value of 7 is? 7. Any questions on those three? You know how to do those, you're good. I got it. The next one's exponents and integers, problem type 2, because I figured problem type 1 was too easy. I took it off the pie chart. There were really like 900 topics I could have had you do. I didn't think you had the time to do 900. So I picked and chose and sorted it down to 250. I could put it back up if you'd like. No? Okay. Keeping in mind that if my negative is not inside the parentheses, it's really a -1. So this really means -1 times 9 squared. If I follow my order of operations, I have to do the exponent before I do the multiply. So I would square 9 first, and then multiply that by -1. So this answer ends up being -81. People always try to say that this is 81 because they forget that these two things are not the same thing, right? One has the parentheses around the negative, the other one doesn't have the parentheses around the negative. So here the negative is squared. Negative times the negative makes it positive, but here the negative is not squared, just the 9 is. So this one, if I wrote it down, it would be -1 times the -2 cubed. I would do my exponent first. -2 cubed is -8. And -1 times -8 is +8. So, if I have negative 1 times negative 9 squared. Negative 9 squared is 81 times the negative 1 in front. Gosh, you guys are not going to talk, are you? Number 5, or the second one on number 5 there, notice the negative is on the outside, so again that's negative 1 times 4 cubed. That almost looks like an equal. Pretend. 4 cubed. 4 cubed is 64. 64 times negative 1, negative 64. Yes, I realize you could punch all of these into your calculator and get the answers. Your calculator does know the order of operations, but once you start getting into having to simplify cubed roots and fourth roots and all of that, if you don't know these things fairly easily in your head, it's going to make life a lot harder. So, number 6. If I do negative 1 times negative 3 cubed, my answer would be 27. And if I do negative 1 times 8 squared, I would get negative 64. Questions on those 3? Easy enough. Just keep in mind that if it's not in parentheses, order of operations. How many of you have seen that before? Everybody, hopefully. Way back, a lot of years ago when I was in school, we did, please excuse my dear Aunt Sally. My kids come home and I say, what are you doing in math? Because I always think I got to know what they're doing in math class. PEMDAS. I'm like, what in the heck is PEMDAS? I've never heard of that. Oh, you're doing the order of operations. I never called it that. But hey, parentheses, exponents, multiplying and dividing from left to right go together. Adding and subtracting from left to right go together. And so if I have a big complicated expression and I think, oh, I've got to do the parentheses, I'm talking about simplifying inside the parentheses, not if there's just one number in the parentheses. So 2 minus 3 here is inside the parentheses. That would be negative 1. I didn't give myself enough writing room because I like to write big. I did inside the parentheses. I'll write it over there. Next thing I have to do is the exponents. So I'm going to square my negative 1, which makes that a positive 1. I'm going to square that negative 1, which also makes that positive 1. So now I have minus 1 times 3. Multiplying and dividing from left to right. Here I have multiplying, negative 1 times 3, so I have negative 1 minus 3. Then I can do my adding, subtracting. My answer then is negative 4. So, inside the parentheses, so you only have one number in each set of parentheses, exponents, multiplying and dividing, then adding and subtracting. So number 8, if I do inside my parentheses, negative 2 plus 4 is 2. Then I'm going to do my exponents. So on the top of the fraction I have 2 cubed, which is 8. So 8 minus 1, I'll write down. On the bottom I have negative 2 cubed, which is negative 8. Now, just because it looks pretty, they'll put parentheses there because they want to separate the subtraction from the negative sign, not that you really have to have those there. I really don't have any multiplying and dividing. Well, I kind of have dividing, but I have to simplify first. So if I do my adding and subtracting, 8 minus 1 on the top, negative 1 minus a negative 8 would be 7, right? Negative 1 plus 8 is 7. And then I can do my 7 over 7, which is 1. Number 9 then. I want to simplify inside my parenthesis because there's not just one number there. 4 over 2 would simplify into 2. So 2 cubed plus 3 minus 4 squared. Doing my exponents, 2 cubed is 8. So 8 plus 3 Minus and 4 squared is 16. Notice I didn't square the negative, I just squared the 4 because there's not parentheses there. And now I don't have any multiplying and dividing, so I can add and subtract from left to right. 8 plus 3, 11 minus 16, negative 5 would be my answer then, right? Now your calculator does know the order of operations. If I punch this problem in just like it looks, I should get the correct answer. However, if I have a fraction in there, either I have to do the top separately from the bottom, or I have to put extra set of parentheses around for my calculator to know, do the entire top and find the answer, do the bottom, find the answer, and then divide my two numbers. So if you are using your calculator, usually I just would do the top separately and the bottom separately and divide, but if you really want to put a lot of parentheses in there, you can do it that way. Questions on order of operations? You guys already knew all that. Pretty easy, I would think so. Properties. Properties of real numbers. Commutative property of addition. Commutative property says you can change the order. So if you look on the ALEKS program, they'll show you something like x plus y equals y plus x. I can switch the order of my adding and get the same answer. 2 plus 3 is the same thing as 3 plus 2. Associative property of addition. Associative, an association is a group, has to do with grouping symbols, parentheses. The order has to stay the same, the parentheses are what is moved or changed. So for the associative property, they'll show you something like x plus y plus z, where you have parentheses around two of them. I'm going to put them around the x and the y. On the other side, you'll still have x plus y plus z, but now your parentheses are going to be moved to around the second two instead of around the first two. So for the associative property, your order has to be exactly the same. The only thing that's different is you move the parentheses. Additive identity property. You want to think about the identity kind of like looking at the mirror. What you start with is what you want to be equal to. For addition, if you add 0 to something, it doesn't change its value. 3 plus 0 is still 3. So the additive identity property will say something like x plus 0 equals x. The whole key there is that you're adding 0 to something which doesn't change its value. Additive inverse property. The word inverse means opposite. The opposite of adding is subtracting. And so the additive inverse property says that if I add two numbers that are opposite, I get an answer of 0. Their example for additive inverse property would be something like x plus a negative x equals 0. 3 plus negative 3 is 0. If I add opposites, I get 0. The distributive property. Well, probably most of you know that the distributive property is used to get rid of the parentheses. They'll show you something like x times y plus z equals x times y plus x times z. They may or may not put the dot in there for times, but I will for effect. So I got rid of my parenthesis by multiplying the x times both terms in the parentheses. Commutative property of multiplication is going to look like the commutative property of addition. So be careful when you're picking that off your list that you're picking the correct one. Am I adding or multiplying? But basically I can change my order. So x times y is going to equal y times x. Again, you really don't need the dot there, but I'm going to put it in there so you remember I multiply. Same thing with the associative property. It's going to look a lot like the associative property of addition, just that I'm multiplying. So x times y times z, where I have parentheses around the first two, is equal to x times y times z, where I have my parentheses around the second two. I just moved my parentheses. Multiplicative identity property. You want to think about the identity property. What I start with is what I want to be equal to. So what do I multiply by so that I end up with the same number? Well, I would multiply by 1. 3 times 1 is still 3. So my multiplicative identity says if I take something times 1, I end up with that same number. X times 1 is still x. Multiplicative inverse. Kind of the weird one. Inverse, we think of opposites. Normally when we think of an opposite of multiplying, we probably think dividing. They're going to think in terms of fractions. When I divide with fractions, I multiply by the reciprocal. So when I take a value times its reciprocal, I always get an answer of 1. So they're going to show you something like x times 1 over x equals 1. If I had 2/3 times 3 over 2, I get an answer of 1. A value times its reciprocal always equals 1. And the last one is the multiplication property of 0. If I take something times 0, hey, guess what? I get 0. So they're going to have you pick them out. On Alex, they're going to have a drop down and you pick which one it is. I'm just going to have you write down the number of which one it is. So here, obviously, this is an adding property, so it's one of your first 4. If I have 3/5 plus n equals n plus 3/5, which property is that?
1.
Number 1, the commutative property. I just switched them around, changed the order. The next one is a multiplying property, so that tells me it's 6 through 10. I have 8 times 4 times 5/4, and I changed it to 8 times 4 times 5/4. And what property is that?
Associative.
Associative property of multiplication. So that's number 7. The next one, 0 equals 2/3 times 0.
Multiplication property of 0.
Multiplication property of 0. I took something times 0 and I still ended up with 0. And then I have b times 1 over b equals 1.
Inverse.
Multiplicative inverse, so that would be number 9. So, there was all my scribbling. If you print out my note sheets, you'll have my notes on that. Or maybe you scribbled that all down, but we had 2 more to do. They just take up a lot of room. So, n times 3/5 equals 3/5 n. Did I go to the right one? Sometimes I skip pages. N times 3/5 equals 3/5 n would be which property? Commutative property of multiplication. So number 6, we just switch the order. They switch those 2 things around, right? The next one, a times c plus 2 equals ac plus a times 2. It's which property?
Distributive.
Distributive. They took the a times the c, then the a times the 2. They got rid of their parentheses. So if one side has parentheses and the other doesn't, pretty good sign. That's my distributive property. 0 plus 2/3 equals 2/3. Additive identity. I added 0 to something which didn't change its value. That's number 3. And then 1/9 times 9 equals 1.
Multiplicative inverse.
Multiplicative inverse. That's number 9. Something times its reciprocal is equal to 1. So number 12 there. The first one would be what property?
Distributive.
Distributive. They took the 3/2 times both the 5 and times the 7. Got rid of their parentheses. So number 5. The next one would be
Associative property of multiplication.
associative property of multiplication, which is number 7. They just move the parentheses on that one. The next one, negative 5/2 plus 5/2 equals 0. Number 4, the additive inverse property. They added numbers that were opposite and got an answer of 0. And the last one, 1 times c equals c. Multiplicative identity property, number 8. 1 times anything doesn't change the value, right? Forgot. 13, 14, 15, using the distributive property and combining like terms to simplify. I'm hoping you all got this right on your pretest, but in case you didn't, we'll do it anyway. If we have parentheses, that's usually the first step, is get rid of our parentheses by using the distributive property. So you did 2 times u was 2u, 2 times negative 4 is minus 8, and the negative 4u wasn't in the parentheses, so you just brought it down. And then you had to combine your like terms. 2u minus 4u would be negative 2u. The 8 didn't have anybody to combine with, so you got negative 2u minus 8 for your answer. Right? Yeah, sure. So number 14, if we get rid of our parentheses, we're going to have
Negative 3y minus 3.
negative 3y minus 3. We bring down the minus 6 and then combine our like terms, so our answer would be
Negative 3y minus 9.
negative 3y minus 9. And number 15, if we get rid of our parentheses on that one,
plus 24.
8u plus 24, and bring down the minus 12u, then combining your like terms,
Negative 4.
negative 4u plus 24. I'm going to assume you all know how to do that. Or you probably wouldn't be here. You guys are working ahead of me? So number 16, 17, and 18 says using the distributive property with double negation and combining like terms to simplify multivariate. Man, they have nice names for these things. So again, I'm going to get rid of my parentheses first. So negative 2 times negative 6u would be 12u. Negative 2 times a positive w is negative 2w. Here, you can think of it as multiplying by negative 1, or subtracting is adding the opposite. It's really the same thing. A negative times a negative makes that a positive 3w. A negative times a negative makes that a positive 3u. And so once we got rid of our parentheses, we then combined our like terms. And so 12u plus 3u was 15u. Negative 2w plus 3w is a positive 1w, which we know by now you don't need the 1 in front. If you put it on the Alex program, at first it reminds you and says it's correct, however, you don't need the 1. Later it starts counting it wrong if you put the 1 in front. So try not to put the 1 there. 15u plus w is in my answer. So number 17, if we're simplifying that expression, we would have to get rid of the parentheses in the middle first. So I'm going to bring down the negative 3x. And then if I multiply by that negative 3, I would get what?
6
Positive 6y
minus 18.
minus 18x. And then we bring down the minus 5 in the middle. Well, here we put the plus sign in front because there was something in front of that, and it's not the leading term, so I put my plus sign there. Now if I combine my like terms, negative 3x minus 18x would be negative 21x, and my 6y minus my 5y would give me positive y. I do notice that some people forget to put that plus sign in there, and then it counts it wrong because it means times y instead of plus y, so just be careful when you're typing in a big long polynomial that you get your signs in there. And so number 18, if we're going to simplify that one, bring down our 4x, get rid of our parentheses, so we would bring down
Negative 6y plus 6x.
negative 6y plus 6x, and then we'll put the plus y on the end. Combining our like terms, 4x plus 6x would be 10x. Negative 6y plus y would be negative 5y. So 10x minus 5y. The next one are the introduction to the product rule of exponents. Basically, the product rule of exponents says that if I have the same base, I add my exponents together. If I thought about it the long way, this would be x times x to the fourth, which is x times x times x times x to the third, which is x times x times x. That's a whole lot of x's there. Well, we can just add them up. 1 plus 4 plus 3 gives us x to the 8th power, right? I've got 8 of them once I expanded it into expanded form. So they're going to say something like x to the m times x to the n is equal to x to the m plus n. When I multiply with the same base, I add my exponents. So w cubed times w to the fourth times w squared times w would be w to the 10. And y times y to the fifth, y to the sixth. You already knew those. Product rule with positive exponents, multivariate. Basically, you're combining your like terms, only you're not adding and subtracting, but you're going to multiply your like terms together. So you're going to start with your coefficients, those numbers in front, 2 times 4 times 6, and multiply those together. 8 times 6 would be 48. And then you're using your rule for your exponents. If I have y to the fifth times a y, I get y to the sixth. And if I have v to the fifth times v to the fourth, again I add my exponents, so I have v to the ninth. Now, does it matter which order I put my variables? No, because I have the commutative property that says I can put them in whatever order I want. In best form, they usually will put them alphabetically, but they're not going to care. So it's up to you. So 23, if I'm going to multiply that, starting with my coefficients, 2 times 2 times 5 would give me 20. W to the fourth times w is w to the fifth, and y to the third times y to the seventh, y to the 10th. So 20 w to the fifth, y to the 10th. Number 24, if I do 2 times 4 times 6, 48. They like that today. Y to the fifth times y to the sixth, y to the 11th, and u times u to the fifth, u to the sixth. So 48, y to the 11th, u to the sixth. The next one is the introduction to the power rule. The power rule basically says if I raise to a power, I multiply my exponents, because if I have w cubed and I raised it to the fifth power, it would mean w cubed times w cubed times w cubed times w cubed. I'd have 5 of them up there. And then my rule is to add the exponents. Well, 3 plus 3 plus 3 plus 3 plus 3, 5 of them would give me w to the 15th. Well, it's a whole lot easier just to say, oh, I raise to a power, my rule is to multiply my exponents. So they'll say x to the m raised to the nth power is x to the m times n. And they'll show you that little rule like that. So if I have x to the fifth y and I'm going to square it, I'm basically squaring the x to the fifth and squaring the y. So I would get x to the 10th and y to the 2nd. And if I have z to the fourth raised to the third power, I would get z to the 12th. The next one, still introduction to the power rule of exponents, but this time they threw the coefficient in front, where I have to remember, oh, I've got to square the 9, not take it times 2. So if I take 9y and I square it, 9 squared is 81, and then y squared obviously is y squared, so I get 9y squared. If I take 2x and raise it to the fifth power, then I would get 32 x to the fifth power, right? Emily's falling asleep. If I take 3w and raise it to the fourth power, I'm getting 81 w to the 4th. It will, same thing, now they think they made it a little more complicated than they had on the other one, but we're still doing the power rule. So if I take 3, square it, I would get 9. If I take my w to the 5th and square it, I multiply and get w to the 10th. And if I take my y and square it, obviously I get y squared. So number 32, if I have negative 2, u, v to the 3rd, and I'm going to raise that all to the 5th power. Negative 2 to the 5th power is
Negative 32.
negative 32. And then I'd have u to the 5th and v to the 15th. And number 33, if I have negative 5, x to the 3rd, y to the 4th, then that's all squared. If I square negative 5, I get 25, and that is positive because I squared that negative. I get x to the 6th and y to the 8th. So, power rule with positive exponents, quotients. If I take w squared and I raise it to the 4th power, you all should know what it is now. W to the 8th. 2 raised to the 4th power, 16, and u to the 4th raised to the 4th power, u to the 16th. Number 35, I'm going to cube that expression. So if I take the negative 3 and cube it, I would get negative 27. The v and cube it, v cubed, and on the bottom, w cubed, and cube that, w to the 9th. Now on that expression, if I type it in like that, the LX program is going to say it's correct, however, the better form for that is to do what with the negative? Put it in front of the fraction, because a negative divided by a positive makes the fraction negative, not just the numerator. So if there's a negative on the top or the bottom, if you put it in there, it's going to say it's correct, however, and remind you that really the whole fraction is negative. And so that's the way they probably want to see the answer. Not that they'll count it wrong the other way. And the last one on that page, if I take v cubed and square it, I would get you guys quit on me. Negative 3 squared is 9. And u squared is u to the 4th. So v to the 6th over 9, u to the 4th power. All right, I know I did those fairly quickly. You guys already knew all that stuff, or most of it.